All right, guys, now that you're done with your quiz, we are going to do a review on solving systems of linear equations. Now, there are three ways that we can solve a system of linear equations. One way is by graphing, another way is by substitution, and the third and final way is a process known as elimination. Now, this is a skill set that you should have learned in 8th grade, but we wanted to go ahead and give you a resource to review. That way you are prepared for the content to come after the quiz. So first, let's do a review of solving by graphing. First thing that we want to do is get it into a graphable format. So you need to get it in slope-intercept form by isolating y. That way you can easily identify your slope and your y-intercept. Okay, then you're going to graph both lines on the same coordinate plane, and you're going to look for the point of intersection. Okay, where they intersect is really where the solution to the system is. That will be the one coordinate that makes both of the equations true simultaneously. Okay, but we could have a situation where there is no solution, right? If the lines are parallel, then they're never going to touch. Therefore, they have nothing in common. So there is no solution to the system. Or you could have lines that are coinciding, meaning you plot this line, you plot the next line, and you realize they actually happen to be the exact same line. They have the same slope and the same y-intercept. So in that case, there are infinitely many solutions. Let's go ahead and take a look at the two worked out cases that are already in your notes. All right. So this is the scenario where there is no solution. We started with plotting our y-intercept at 2 and building our slope of down 1, right 3, down 1, right 3. Okay, then for the next line, right, our y-intercept was at -4, but our slope was still down 1, right 3. So without even graphing this, we should have been able to make the conclusion that there would have been no solution because they have the same slope but different y-intercept. Therefore, the lines are parallel. Therefore, they never touch, so they have nothing in common. Okay, you're going to do example number 1 for your own practice, and we'll review that answer key tomorrow. Then if we look at 3 and 4, now question number 3 you're going to do on your own. Question number 4 we have worked out for you. Now notice these are not in the form y equals mx plus b, so we're going to actually have to convert it. If you take a look at the first equation, we can start with adding x to the other side. Once you add x to the other side, it's now in slope-intercept form. Then we'll convert the second equation. We can add 2 to the other side. Once you add 2 to the other side, it is then in slope-intercept form. After plotting both of these lines, right, my y-intercept is at -3. My slope is up 1, right 1, up 1, right 1. This one, my y-intercept is at 2, and my slope is 6. So down 1, 2, 3, 4, 5, 6, to the left 1. Now notice where they intersect is the solution. Both of the equations would be true if you were to plug in this coordinate value. What you're going to do in this case is go ahead and convert this one into slope-intercept form. This one's one of our special cases. You got to decide, is that a horizontal line or a vertical line? Go ahead and plot them and see where the intersection lies. Okay, the next way that you could solve a system is by substitution. Okay, so substitution, right, is a fancy word for plugging a value in. So you're going to solve one of the equations for one of its variables. I like to choose the easiest one if possible. For example, y minus 2 equals x, 2x plus 10, right? It'd be really easy to get y by itself in this example by just adding 2 to the other side. So usually I try to look to see if there's an easy option to isolate a variable. Okay, then what you're going to do is substitute that value into the other equation, and then we're going to finish solving. Plug that value back in and then find your second part of your coordinate. So let's go ahead and take a look at an example together. For this one, let's see, we will do question number 2 on video. So I'm trying to decide what might be easiest to isolate. it looks like it might be easiest if I take this first equation and I isolate our y value. To isolate our y value, we could add 4x on both sides. That would leave us with y is equal to 4x minus 8. Now, everywhere that I see y, I could substitute in the value 4x minus 8. So notice inside of our second equation, I'm going to substitute in the value of y. So step 2. We have 2x minus 2 times, let's plug this in. All right, now we can go ahead and solve for x. I can begin by distributing, so 2x minus 8x plus 16 is equal to negative 14. I can combine my like terms, so negative 6x plus 16 equals negative 14. I can subtract 16 on both sides. So it looks like negative 6x is equal to negative 30. And we can divide by negative 6. So it looks like x is equal to 5. Now that I know what my x value is, I can then substitute that back into either of the equations. So my final step, take my x, plug it back into either equation. I'm going to plug it into the first one. If I substitute that in, we get negative 20 plus y equals negative 8. We can add the 20 to both sides, so plus 20 plus 20. So it looks like y is equal to 12. Therefore, the solution to the system is 5, 12. Okay, what you're going to do is work on the remaining examples for practice. All right, and then last but not least, we're going to go over an example of elimination. Okay, here are the directions for solving by elimination, so feel free to look on those while you do start your problem. But let's do one example on video. Okay, I'll do this example right here. Now notice I want to find something that I want to eliminate. If we were to add these equations together right now, nothing would eliminate, but we have a negative 9 and a negative 9. If I can force that to become a positive 9, then we'll have a scenario that eliminates. So I'm going to multiply the entire second equation by negative 1. When I do that, that becomes a positive 4x, a positive 9y, and a positive 23. Now that I've altered this equation, I'm just going to cross it out and ignore it. Now we can add these two equations together. Notice when I add negative 2x plus 4x, I get 2x. When I add negative 9y plus 9y, those eliminate, hence the word elimination. Negative 25 plus 23 gives us a negative 2. And now I can finish solving for x. Divide by 2 on both sides. So it looks like x is equal to negative 1. Now that I know what my x is, my final step is going to be to plug that back in or substitute that back in to see what my y value is. So negative 2 times my x. That would give us a positive 2. I can subtract 2 on both sides. I can divide by negative 9 on both sides. So it looks like my y is equal to 3. So negative 1 comma 3 would be the solution to this system. Okay, the remainder of your homework for tonight is to finish solving the rest of the practice problems using the examples I've shown. Again, this should be your review from 8th grade, but we wanted to give you an opportunity to kind of kick off the rust and to practice a few examples before tomorrow. Good luck and come see me in the morning if you have questions.